So in the previous tutorial, we simply used a cube. Out of this box, through box modeling, we're going to be making an avatar. Now, just like the cardboard box you use to pack your stuff in when you're moving out of your place, it consists of 6 faces. Each face, each quadrilateral, consists of 2 triangles. These 2 triangles are broken down into vertices. Each one of these vertices have something called normals. Depending on which way these normals face in relation to the camera will determine how they are being shaded. Now I'm putting all of these together to form objects. Each object then can be put together to create a model. So in our case, it's the block mapping. UV mapping is a way to get textures onto the object. When we unwrap all of these, then we'll get proper texture mapping. Each one of these cubes, these boxes, is unwrapped. We will have 6 faces, which will be mapped to the texture, which is represented at the right side of the screen. All of these are virtually a Cartesian system of x and y coordinates, but is referred to as respectively u and v. Okay, so it seems that we have proper mapping. Now we're going to be applying a texture onto this in order to actually demonstrate that the UVs have been properly mapped. All of these, of course, will be available online, and you do not have to do this if you don't have experience. So in rigging, we will be putting together a hierarchical structure in order to animate each object. Now, in our model, we do not have a structure based on a hierarchy. Instead, everything is based on the root level. But in this case, we want to move each one of the bones in according to its parent bone. For example, I want to move the forearm in accordance to the bone of the shoulder. So you can see I'm going to be placing the bones exactly where my mesh would have the proper parts. If you don't have that, if you don't have the hips at the hip part, the elbows at the elbow part, the phalanges, the fingers, and etc., then you will not have proper mesh deformation. In this case, I'm not going to be needing all parts of the mesh, so I'm going to shrink some and simply delete the other ones. In fact, considering the cubes that I'm using are not subdivided, we will actually not need too many bones. Okay, I'm just going to align these in 4 views, and then I'm going to map all of these. I'm going to weigh all of these bones against the skeleton with just automatic weights. And let's see how it deforms. Okay, well, that looks okay for what we're building. In animation, we're going to be taking this rig and applying it via different cycles and different clips. Some clips, such as an idle cycle, are needed to be looped, considering the character is constantly going to be doing that. And for each loop, we want to make sure that they're matching, otherwise we're going to have some jerky motions. Some clips don't need to be looped, however, such as, for example, the jump cycle. A jump does not need to be looped. Even if the character is constantly jumping, all of these are going to be triggered actions. A walking cycle will need to be the same thing because it won't be triggered by one button, it'll be continuously happening. You can see that I'm going to be testing whether they loop properly, and in this case they are. Now keep in mind, all of these turns and all of these rotations are based on something that's called an Euler. And an Euler is a system of hierarchy of rotations which typically are very convenient to be used for animations. It has several problems, however, such as, for example, gimbal lock, in which all of these axes will then align. This is solved by Unity by using something called quaternions. And you can see I'm having some problems rotating as well here. So uh, you can have turns for over 360 degrees, so they're going to be spinning continuously, or you can have turns that go out of these axes and really have some unexpected rotations. Now, quaternions you don't actually need to understand to do most animations in Unity. In fact, even though it uses it fundamentally, it uses it under the hood, you can still animate with Euler curves, and you can still bring in Euler curves from any modeling package of your choice. So what I'm going to be doing here is I'm going to be taking the first frame of the clip and I'm going to copy it to the last in order to get a complete and proper cycle. Okay, so without all of the jump, idle, and turn animations, I will do them and pause the video for a second while I finish. Okay, so it seems that we have all of the animations that we need, so let's stop this model for now, and everything seems to be set up, and move on to level creation. In level design, we would have a system of collisions, so our character does not go off to the side and also does not fall through the floor. I'm going to be creating this out of a simple cube. And while we could be using each asset, we could be using rocks or any doors or anything else to create a system of limits in which a character can move. I'm going to be creating this out of a cube and then placing each object without colliders, unless I specifically need them. So this would be just a more convenient way instead of having a lot of colliders in all of the objects. Instead, I can simply hide this object when the level starts playing, and then use it as a schematic, as a skeleton, in order to place my level. So I'm using a 4-window layout to get a more easy architectural view. So we don't need all of the top faces because we're not going to have a ceiling. Okay, and it seems our level is more or less set up. I'm going to give it a simple polka dot texture. Okay, so we'll do one more thing, and it's going to be a sphere that will surround the level. Okay, and we're going to give it a pretty crazy texture, which I simply just made from a noise filter. Now we're going to be using a particle system as well, so let's give it some sort of sprite which it will then duplicate in every single one of the particles.